Hello again and welcome to my channel Professor Learnwell. In this lesson we are going to be looking at a number of 3D shapes and their properties. 3D stands for three-dimensional because the 3D shapes are made up of 3 dimensions, normally length, width, sometimes called breadth, or depth. If you think of perhaps a swimming pool, you might swim a length, you might swim a width or a breadth, and when you're diving into the pool, you would dive down a certain depth. But when we're thinking about 2 dimensions, 2D shapes, we're thinking more of a flat shape, where it's made up of 2 dimensions, just the length and just the width. Another word for width is breadth. So we're going to start off with this shape, and on this video we're going to go through 5 3-dimensional shapes, and then in the next video we'll look at 5 more shapes, and that then will have included most of the shapes that you would encounter at school, and quite possibly in everyday life around the home. One good thing to do with objects around the home is to try and recognize and name certain 3-dimensional shapes that you'll see. So there are certain vocabulary that we need to use: vertices, edges, faces. The singular for vertices is vertex. So we have to see what a vertex is, and in everyday language it would normally be called a corner, but in mathematical terms this is a vertex. And how many vertices does this particular shape have? Well, let's count them. Now, 1, 2, 3, 4. Turn it round. 5, 6, 7, 8. So on our worksheet you would write number 8 just there. Now at this point in the video I'd like to mention that these worksheets are available as free downloadable worksheets from the website the TES, and that's short for Times Educational Supplement, and I'll put the link to that page at the end of this video. I would also like to mention at this point that as well as having page 2, I've done the same worksheets in a landscape view, which might be more pleasing to some people who prefer to work that way. So they're all available at no cost on the TES website. Right, so I'm going to write in here 8. So if you've managed to download one of these worksheets and print it off, you might like to pause the video and then try and write your answers ahead of mine. Now the number of edges. Now you probably realize that these are the edges. So on the top half we've got 4 edges, and if we move down 5, 6, 7, and the one you couldn't see 8, turn the shape round 9, 10, 11, 12. So this particular shape has 12 edges. The number of faces are the 2-dimensional shapes that make up, when they're put together, a 3-dimensional shape. So this flat shape at the top here, 1, 2, 3, 4, the one you can't see, 5, and the one at the bottom, 6. So this particular 3D shape is made up of 6 2D faces. Now, where my worksheet differs from any others is that I've got an extra column here because I thought it would be useful to name the 2D faces. Well, in this particular regular 3D shape, the 6 faces all have the same name. And because the length is the same as the width, and they're 90-degree angles here, right angles, these are squares. This particular shape is made up of 6 squares. So, can you name this shape? Made up of 6 squares, it is a cube, which is spelt like this. As you can see, gone back to joined cursive writing. Right, let's put that to side for one moment, and we'll take our second shape. And the properties are very similar to the shape we just looked at. This also has 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. The properties of this shape are so similar to the cube that it also has the same number of edges. 1, 2, 3, 4, 5, 6, 7, 8. Turn it round. 9, 10, 11, 12. 12 edges. And in fact, it's so similar that the number of faces are the same as well. Six faces. 1, 2, 3, 4. The one at the back you can't see. 5, 6. The difference, though, are the names of the 2D faces that make up the three-dimensional shape. Well, these are not squares because the length is longer than the width. It looks a bit more like a swimming pool. You'd swim the length, or you'd swim the shorter distance, the width or the breadth. Or you might dive the depth. This shape is a special shape, and it's called a rectangle. Many people will call this an oblong rectangle because it's not a square rectangle. A square is a certain type of rectangle, a regular rectangle, because all the sides are the same distance. But when the longer opposite sides are a different length from the shorter ones, well, that's pretty obvious from the language I'm using, then it's an oblong. It's still a rectangle, but an oblong. But I'm going to write the word rectangle up here. And this does cause some confusion. A square is a regular rectangle, and an oblong is an irregular rectangle. Now, the shape, this we give to the three-dimensional shape. The word we give to it is similar to the cube, and it's called a cuboid. And that's the spelling of cuboid. Now, let's move on to our third shape. I'm going to tell you what the general name for this shape is. It's a prism. You could say that a cuboid or a cube is a certain type of prism. This is the more conventional looking prism that you perhaps see in scientific diagrams of light rays shining through a prism to bend the light rays, which of course we wouldn't be able to do with this as it's an opaque surface, not transparent. So let's have a look at the number of vertices. The number of corners, strictly speaking, vertices 1, 2, 3, 4, 5, and 6. These, by the way, are ink marks. 6 vertices. The number of edges. Well, you can see quite clearly 3 edges here, And it must mean there are 3 at this side. So that's a total of 6. But we've got some more edges to count. This one, 7, 8, and the one at the back, 9. Now the number of faces, and if you do get confused when trying to count the number of faces, you're worried you've missed one out or you counted one twice, you can always write in a non-permanent marker pen 1, 2, 3, 4, 5. Now we can see that these faces in a prism are always made up of rectangles. In this case, they're oblong rectangles. They don't happen to be squares. So we'll put rectangle. And there are 3 rectangles. And the 2D shapes at the end, what are they called? Triangles. I'm sure you knew that. And the word triangle gives a clue to the special type of prism this is. It's called a triangular prism. So do pause the video at any time you want to write your answers ahead of mine. Triangular prism. 2 more shapes to go in this video. The next one is this shape. Now, this can be a little bit tricky to describe. So we'll think about the number of vertices. Well, there's only 1. What about the number of edges? Well, there are no edges, any sharp points around here, sharp edges here, that's the point. So there's 1 vertex, as I mentioned. But this is an edge. Goes on and on and on, and it's a 1 edge. So we had 1 vertex and 1 edge. Now the number of faces, well, this clearly is 1 face. And this actually is 1 face as well. It's a continuous 1 face. So the number of faces were 2. And to show you that, I have made a net of this particular shape. A net is the word we give to describe, it's a bit like a map of a 3-dimensional shape. If we cut out this shape here, and we cut out that, but try and leave them joined, although it's not essential. If we folded that round, we could recreate the top half of that shape. And there you can see we've got that face there. So that shape is a circle. I'm going to put S for circles, because this actually is part of a circle. If you continued this line round here, you'd see we have the segment of a circle, slightly more than half. And the amount of the circle would determine how tall and spiky this 3-dimensional shape would be. Spiky is not a mathematical term, I hasten to add. So that's the net of this particular shape, and it is the net of a cone. Most pupils remember this name because they can think of an ice cream cone. Spelt Now, our last shape for this particular video, just reach for it over here. How to describe this? Are there any vertices? No, there are no vertices on this special shape, and there are no edges either. So, in this box over here, it's a 0 or a 0. The number of vertices, there are no corners, no vertices, and there are no edges that you can run your finger along. This was an edge, but this, as you can see, no edges. The number of faces. There is only one face on this particular shape. And the name of this 2D shape is very hard to describe. If you think of peeling an orange and taking off the peel in one complete section, you would not be able to lay it flat. So I'm going to leave that blank. And the name of this is a sphere. Thank you for listening to this video. In our next video, we'll go through the shapes in the second sheet. So that'll be coming up in a moment.